Okay, today we are looking at a subtopic, finding the equations of tangents to functions. Remember what we have talked about. Average gradient is the gradient between 2 points, and it is defined by m is equal to y2 minus y1 all over x2 minus x1. Or the same average gradient can be defined by m is equal to f of x plus h minus f of x all over h. The derivative gives the gradient of a point on a curve and is given by the derivative of any function is actually the gradient of a point on a curve and is given by f dash of x is equal to limit of f of x plus h minus f of x all over h as h goes to 0. Boys and girls, listen carefully here. When the question does not demand that we use first principles or definition, we use the rules that we have discussed in some areas of our study. So use derivatives and their rules, except if asked to use the definition or to derive from first principles. I'm going to go through this example with you, example 1, and I'm going to read. Consider the function f of x is equal to minus x squared plus 2x plus 8. Then part A is saying determine f dash of x. This question does not demand us to use or to make use of definition or first principles. So we are going to answer this question straight by use of rules. So our f of x is equal to minus x squared plus 2x plus 8. So our f dash of x will be equal to the derivative of the function, which is minus 2x plus a 2. We did not use first principles or the definition. We just used our rules. Part B says, we are now looking at part B, and I read, determine the equation of the tangent to f at the point where x is minus 3. That is part 1. Part 1, we are saying we want to find the equation of a tangent to f at the point where x is equal to minus 3. If x is minus 3, then the gradient, which is the same as f dash of x, is actually given by minus 2 multiplied by x, which is minus 3 plus a 2. And this will give us 6 plus 2, which is equal to 8. Now we have the gradient. What else do we need in order for us to find the equation? We now need the y coordinate when x is minus 3. So our y, which is f of x, will be given by minus x squared plus 2x plus 8. Now we are substituting our minus 3. So this will give us minus 3 squared plus 2 times minus 3, then plus 8, which gives us minus 9 minus 6 plus 8. Now if we add this and this, we get minus 15. Minus 15 plus 8, that's minus 7. So we are saying when x is minus 3, what is y? Minus 7. So we have a point, we have a gradient. So straight away we use our equation y minus y1 is equal to m bracket x minus x1, which then gives us y minus minus 7 is equal to, that's 8 bracket x minus minus 3. So this will give us y plus 7 is equal to 8 bracket x plus 3. Y plus 7 will then gives us 8x plus 24. Now our y therefore will be equal to 8x. If this one goes there, 24 minus 7, that's 17, so plus 17. This is the equation of the tangent to this function f at the point x is minus 3. Part 2, we have x is equal to minus 2. Again, the procedure is followed throughout. I'm going to do this one, then the other 5 that are remaining, I'll just state them. There are actually 4. 1, 2, 3, 4. I'll just state the equations as they are calculated for us. So when x is minus 2, again, we want to get the gradient at that point, which is f dash of minus 2 actually, if you want, is equal to, we are substituting minus 2, so it's minus 2 times minus 2 plus a 2. This will give us 4 plus a 2, which is equal to 6. This is our gradient at x equal to minus 2. What else do I want? I want the corresponding y value. This is minus x squared plus 2x plus 8. So at this point, I'm substituting who? A minus 2 for x. Minus 2 squared plus 2 times minus 2 plus 8. This will give me minus 4 plus 8, which is equal to 0. So there is a point minus 2 and 0. Again, using the same equation, y minus y1 is equal to m bracket x minus x1. We are now substituting the point minus 2 and 0. So it's y minus 0 is equal to gradient. We got a 6 into x. What is our x? Minus 2. That's our x is minus 2. So this will be y is equal to 6 bracket x plus 2, which then gives us y is equal to 6x plus a 12. This is the second equation. So we have how many parts? 1, 2, 3, 4 left. So part 3, I'm simply going to state, you use the same procedure like we have done there. If you are to calculate them, you get your equation as that's the first one is y is equal to x plus 8x plus 17. We got it. The next one is y is equal to 6x plus 12. We got it. And the next one for x equal to 0. We are now talking about x equal to 0. The equation is y is equal to 2x plus 8. Please take note of that. I did not go through the same procedures because it will be repetition of what we have done. Then part 4, we have the equation again as y is equal to 9. Y is equal to 9. And finally, we have x is equal to 2. This was when x was equal to 1. And here is x equal to 2. When x is 2, our equation is y is equal to minus 2x plus a 12. And finally, part 6, we have x equal to 4. Our x equal to 4. So the tangent will be y is equal to minus 6x plus 24. So all these are the equations that we need to know. I'm putting a star just to show you where the equations are. The equations through a certain point on the curve. Wherever I put a star, these are our equations. That was part B. Now we are looking at part C. Part C says, which tangent in part B passes through the turning point of F? Now, for us to identify any line as a tangent and it's passing through the turning point, it means it has got only a variable y. So of all these, it's only in part 4 where we had y is equal to 9. So it is actually y equal to 9. And you tell us that it's because it is passing through the turning point with coordinates 1 and 9. Very, very important. These are the coordinates of the turning point of this graph. Then we are looking at part D. I am not going to show you everything, but I'm going to simply show you how to sketch the quadratic. Remember, with the quadratic, what do you need? You need the turning point, you need the x cut, you need the y cut. From here we can see the y cut is 8, so it will actually pass through a point 8. Very important for us to see. And we can see at point 1 and 9, which is somewhere here. I will indicate 1 and 9. That is our turning point. And we can also see that when y is 0, it will pass through -2 and 6. So we shall have our 6 here. This is a 1, so this is a -2. So our graph will go like this. It's a quadratic function that goes like that. Then for all these, use the intercept method. The intercept method is when you say when x is 0, y is 12. I'm looking at this one now, part 2. And when y is 0, x will be -2 when you solve here. So you just need 2 points and then you draw your straight line. Thank you very much. I think we can move on to part E. Part E is saying, for which value or values of x is f, part 1, an increasing function. Now here I'm going to bring you back to the textbook. I want to show you what we are talking about here. We are saying, where is the graph an increasing function f? An increasing function is identified by tangents. When the tangents have got positive gradient, then it's an increasing function. When the tangents have got negative gradient, then it's a decreasing function. I hope that is very clear to everyone. So when you are looking at all this, you notice that this one has got a positive gradient, this one has a positive gradient, this one has a positive gradient. So I've got 3 of them with a positive gradient, which means this part of the graph up to here, the turning point now, which is 1, 9. Remember our turning point, we said it's 1, 9. So this part of the graph has got positive gradients because the tangents are having a positive gradient. Therefore, we can say when x is less than -1, or not -1, but when x is less than 1. So we are saying it's increasing when x is less than -1. Very, very important. And then where is it decreasing? It is decreasing when we look at a tangent at that point. The tangent has got a negative gradient. This equation has a negative gradient, and this equation also has a negative gradient. Therefore, we can safely say this is increasing, and we can safely say x is greater than 1. It is what? Decreasing. Please understand that. So these are the 2 questions that we were asked, and then stationary. A function has got a stationary point if the gradient is not defined. In actual fact, I cannot say it's not defined, but when the gradient is 0. because remember what we said, y is equal to 9 was a tangent at the turning point. But this can be written as y is equal to 0x plus a 9. So it means the gradient is 0 at the turning point. That is why this disappears and we remain with y is equal to 9. Very, very important for you to understand, boys and girls. Then the stationary point is a turning point. All turning points are what? Stationary points. All turning points are stationary points. Then part F, it says, briefly explain how you use gradients of the tangents in 2 above to do what? To answer 1,5. In other words, we are answering an increasing and a decreasing and a stationary. And I was actually talking about this when I was getting the increasing and decreasing part of the function. Now, it is important for you to realize that we can use the gradient to explain whether a graph is decreasing or increasing or decreasing. If it is increasing, the gradient of the tangent is always positive. That's one important thing that you need to remember. If it is decreasing, the gradient of any tangent on that part of the graph will always be negative. And therefore, once I have the equation of a tangent to a point and it gives me a negative gradient, I'm able to say the graph on that part of the graph, it is decreasing. But if it gives me a positive, it is actually increasing. We are going to do the following in our books. Classwork, it will be exercise 8, and I want you just to do number 2. And then you'll do homework, exercise 8, you'll do number 1. Thank you very much.